All right. Hello, everyone, and welcome to day 2 of the Cobot Expo series Welding and Metal Fab event and our final live demo of the day. So I have with me on the line Matt from Ultraflex Power Technologies, who is going to be running us through a pretty exciting demo for you guys, automated induction brazing with Cobot. So we will take questions throughout this session. Feel free to drop those in the chat box, and I will get those answered for us at the end. So without further ado, Matt, the floor is yours.
Thank you, Jen. So today I'm going to be demoing our Dragon 15 automated brazing system. In this case, we are using an induction power supply in order to automated induction braze several different types of joints. In this case over here, I have set up a 1/2-inch copper to copper joint, a 1/2-inch copper to stainless steel joint, as well as a 5/8-inch diameter copper to copper joint. In this demo, I'm using an Ultraflex W15 induction power supply paired with our HS15. And then where we actually collaborate with the Universal Robot program is with this automation unit, which we call the RoboBraze. The RoboBraze allows you to bring the induction coil to the joint. And using universal ladder logic programming, you're able to tell it to go to the same position in space relative to the Cobot every single time. So if you fixture your parts in the same position, then you're going to be able to go and braze them over and over again. So a little about induction in general. Right here, we have a power supply, and that power supply is going to take your wall voltage and it's going to convert it into a high frequency electrical current. And that high frequency electrical current is going to be sent into our heat station, which has our tank circuit. And then that's going to send it over to the induction coil itself. Now, when the high frequency electrical current is flowing through the induction coil, it produces an alternating magnetic field inside of the coil. And when an electrically conductive workpiece, in this case, our copper to copper brazing joints, is presented inside of the coil, it induces little currents inside the actual workpiece itself that are called eddy currents, and through resistive losses is how you actually heat up the part. So unlike torch brazing, it's actually heated from the part inside out rather than an external source such as the flame. So I'm going to go ahead and run our automated program. In this case, the induction power supply is turned off, so you're going to see that the robot's going to go into position that it was programmed to go to, which is right over the joint. And it's going to pause there. And right now in the program, it's telling it to turn the induction power supply on, which would heat the joint. But in this case, it's turned off. So it's just going to pause there for a little bit. And then when its time cycle is done, it's going to back out and go over to the next joint and keep going. Some advantages of induction brazing over torch brazing is that it is much safer process and it's much more easily automated. Another big key point that we hit on is that it is completely carbon neutral. We are not burning any gas inside of the power supply, and therefore we don't use any carbon emissions when heating up our parts. It's straight electrical power from your wall right into the part itself. So as you can see, it's going from joint to joint and pausing in the middle. Like we said, that there's no actual heating going on right now. But in a little bit, I'm going to turn on the induction power supply and we'll see it actually get up to brazing temperatures in a pretty decent time cycle. One key point with induction is going to be your choice of brazing material. A very popular option in the HVAC industry is copper to copper joints. Copper is actually not the most induction friendly workpiece, and this is because it's very electrically conductive, which means that we're not able to generate many resistive losses via the eddy currents. As you'll see in a little bit, unlike this copper to steel joint, the steel will heat up very efficiently when presented into the induction field, and that's because it is much more electrically resistive than the copper is. So I'm going to go ahead and turn on the induction power supply. And while it's booted up, I'm just going to touch on the fact that when paired with the universal robot pendant, we have all the wiring done behind the scenes that you're going to be able to completely control all functionality of the induction power supply all through the robot programmable software. So you'll be able to use any analog or digital inputs or outputs to really fine tune your process and get exactly what you want to happen. So in this case, I'm actually going to go ahead and braze the 1/2 inch copper to copper joint. So just like any other brazing process, we use a little bit of white brazing flux on the joint, and that's just to clean up the joint before the brazing process, so no oxides prevent the flow of the alloy. In this case, I have a preformed silver-based alloy ring, which we're going to place over the joint. And this is the most ideal case because it's going to present alloy to the whole circumference of the joint. Whereas if you're feeding from a single point, like in most traditional processes, you're relying on the wicking of the alloy round to completely fill the void of the joint. So now that I've fluxed up the joint and placed the preform over the joint, I'm going to go ahead and click start on the robot program. And we're going to run through the same exact program before, but this time we're going to turn on the induction heat. And you can start to see some smoke coming out of the part because we're rapidly heating the copper itself. And as you see, we're going to get red hot. And we actually are reaching brazing temperature right about now. And it's going to stay there for a little bit. And it's going to back out and go to the next joint. In this joint, there's actually a little bit of a Lorentz force that pushed the part out of the coil. But as you can see, we're going to position the coil over the copper first. That's because it's less efficiently heated. And you see, as we bring it up to temperature, it's going to get red hot. Then we're going to scan up the coil to the steel, which heats much faster. And then we're going to go over to the larger joint. The larger joint, just because of its larger diameter, is going to take a little bit more time because we're using a constant amount of power to heat up a larger amount of mass. But as you see, we're still within, I'd say, about a 20-second time cycle in which there's a lot of room for improvement just based on the power supply that you match with this system. Like I touched on before, we are currently using a Ultraflex W15 power supply that's capable of outputting a maximum of 10 kilowatts. But we have also paired this automated brazing system with 15 and 20 kilowatt power supplies. With the larger power capabilities, you're able to put more energy into the same part, which means that you're going to be able to braze them faster. So a couple key points about the flexibility of the automated Dragon 15 brazing system is that you're able to store hundreds of programs all in this universal robot pendant. This comes in handy when you're working with large manufacturing processes and you have lots of different configurations. You're able to assign a program to each configuration, and then you can fixture them as you would like, and the robot will remember the position by position based programming from every single cycle. So as long that you fixture the parts that you can present it to the induction coil the same way every single time, you're able to guarantee that the same amount of energy is put into the part every single cycle, in which you should see the same exact temperature profile across the parts every single time. There's a couple additional options we have paired with this RoboBraze system, and those include temperature control, wire feeder, and data logging capabilities. So if you would like to tap into the serial communication available from the Ultraflex power supply, you're able to get a case-by-case breakdown of the current, power, voltage, frequency, and if available, the temperature profile for every single cycle. So that if anything goes wrong in your process, you're able to pull up exactly where it went wrong and really dive in and see why it went wrong. We have implemented also a barcode scanner into the RoboBraze system. in which, like I just touched on before, you could have many different assemblies that require many different robot programs. And you don't want to go ahead and manually select the program every single time, in which case you can assign each different part number a different barcode. And then when you sync that up with the universal robot pendant, you're able to scan the barcode, and then inside the program, it will understand which barcode you scanned, pull up the associated program, and run the cycle. So we touched on highly repeatable process using induction heating. So as long the parts are positioned the same way every single time. So to prove this, I'm going to just run the same program I ran again before, and you're going to be able to see that you should get more or less the same exact heating cycle. So we're going to go over to the joint. And you'll see we're going to start to get red hot again. And the part has reached brazing temperature again. It's going to back out, go to the second joint, and run the same exact cycle. So here again, we focused the induction foil over the copper because it's less efficiently heated. And as you see, once we bring it up to the steel, it gets red hot within a couple seconds. In this case, we are using one of our standard brazing coils for up to 7/8 inch diameter pipe. We offer many different standard brazing coils ranging from sizes as small as 1/8 of an inch all the way up to about 1.5 inches. Each coil is designed for the maximum part diameter that it's assigned to. And obviously you are able to fit in anything smaller. The key point there is that if you put a smaller pipe into a larger coil design, then you're losing out on some efficiency points. All this is going to do is going to add some time to the total cycle that you're going to reach the brazing temperature because that efficiency is going to drop. Ideally, the part has a close coupling gap to the coil, in which the coupling gap is defined as the outer diameter of the pipe in ratio with the inner diameter of the coil. So one of the additional options that I had brought up before was the use of an optical pyrometer in order to get temperature data on the part, in which case there's two ways you could utilize this. You can set it up off to the side and monitor the part as it heats up, or you can mount it on top of the robot, and we would design a coil such that the pyrometer is aimed at the part in the center of the coil at all times. You're able to use a closed loop PID controller with the Ultraflex power supply in order to maintain a certain temperature. If there's a process in which you need to bring it up to temperature and soak for a little bit, then you can put the automation of a completely controlled temperature loop so that it doesn't exceed a maximum temperature programmed in through the universal pendant. The wire feeder option is one where it can also be mounted on top of the RoboBraze automation unit, in which also controlled by programming through the robot, the universal robot pendant. You are able to specify a feed rate of alloy, and it will feed for that amount of time through a single point during the cycle. And you can, that's to avoid the use of preform alloy rings. Just from experience, we have seen that preform alloy rings are the best case scenario when using automated induction brazing. And this is because it guarantees the same amount of alloy presented to the whole joint every single cycle, in which the operator would just apply a little bit of flux onto the joint, apply the preform ring, put it in the fixture, and then hit go on the robot program. So just one more time, I'm going to run through the same robot program.
Matt, I think we lost your camera. There we go.
Oh, I'm sorry about that. So we clicked play on the robot program again, and it's going to run through and deposit the same energy into the part. And it's going to then wait a little bit and then back up and go to the second joint and run again. So in a real production scenario, we would take out the completely brazed joints and replace them with new fluxed and with a preform alloy in the same fixture, such that it's presented to the induction coil the same way every time. But in this case, I have just kept the parts in the coil and ran the same program. And as you can see, we are getting an identical heating pattern every single time. All of this is programmed in using the robot software, using a power versus time curve, in which I am programming the robot to stay at the joint and apply a specific amount of the induction power supply for a certain amount of time. You can use a temperature profile as well, but you would need that additional option of the optical pyrometer in order to use this feature. And that concludes my presentation today. So Jen, if there's any questions, feel free.
Perfect. Yes. Thank you, Matt. We do have a couple questions. Anyone that has not gotten a chance to drop theirs in the chat, please do so now, and we will try to get through those. The first one, Matt, if someone wants to see or evaluate if this would fit their application, how can they go about working with you guys?
Yeah. So if you would like to see your parts brazed, then you can contact any 3 of our offices. We have one here in New York, we have one in Europe in Sofia, Bulgaria, and we have one out on the West Coast in California. If you reach out to the office, any one of those offices, you're able to get in contact with a salesperson in which they will evaluate your process. And if you would like to send samples, we do offer 4 hours of complimentary lab testing, in which we will heat your parts and send a video and a quick report to see if it's a good fit for your application.
Perfect. Can you talk a little bit about safety with a solution like this?
Mm-hmm. Yeah, in general, induction is a very safe process. One of the key points, which there are labels on the machine, is that we are producing a magnetic field. So anyone in the case of has a pacemaker or any sort of metal implants in their body, they should keep a safe distance away from the system itself. And by a safe distance, in the case where there's metal on your body, we would recommend about a foot away from the equipment. And with pacemakers, we would like you to stand a little farther back, about a 6-foot radius from the equipment is utilized. Another big safety point is that while nothing actually gets hot except the part, there is high current and voltage on the actual induction coil. So we do not recommend touching it, just as you wouldn't touch the flame if you were torch brazing. You shouldn't touch the induction coil while it's running.
Perfect. Now, the Dragon 15 is a Universal Robots Plus certified product, correct? So can you maybe elaborate what that means for a customer when they go to get up and running with this product?
Yeah, so we went through the process of certifying our attachment with Universal Plus. And what that means is that we do have a custom software plugin. So when you are programming your robot programs, you don't actually have to go in and do all the nitty gritty assigning digital inputs and outputs. We actually did all the behind the scenes work there, so that there's just an easy button that says heat on, and then there's a power level button. And then you can automatically put that into your program. You don't have to do any wiring or anything by yourself.
Perfect. So on that similar note, what kind of support does Ultraflex offer if maybe it's still a little intimidating for someone?
Mm-hmm. Yeah, absolutely. We understand completely that the whole process can be intimidating. in which we've implemented systems like this multiple times. So what we do is we normally walk the customer through the steps of their first couple programs, and we do offer on-site support in startup so that a representative from Ultraflex will go out, meet you, install the system, and give you a little training session on how to program the robot, how to use induction power supplies in general, and offer any support. As I touched on before, we have offices across the globe, so our support system is pretty much up 24/7. If you reach out to us, there's bound to be someone around the world that will be able to help you out.
Perfect. All right, well, that looks like all the questions for us today. I do want to encourage all of you to stop by the Ultraflex booth in the virtual exhibit hall. Check out the really great content they have loaded up for you in there. And likewise, if you have additional questions for Matt or anyone else at Ultraflex, you can reach out to them via their website or through their virtual booth. So, Matt, any closing words for us?
Not from me, just feel free to reach out to any of our offices directly if you have any questions or any inquiries.
Perfect. All right, well, that will wrap it up for us today. Thank you, Matt, for a great demo, and thank you everyone for tuning in.
Thank you, Jen.
Enjoy the rest of the event.